All right. So we're going to talk about complex numbers today, and this directly relates to solving by square roots. So we got to talk about what happens when that number that we're taking the square root of is not a good number in the fact that it's a negative number. Okay. So anytime that we take the square root of a negative number, we're going to use this little definition here that the square root of -1 is I. Okay, that's the thing we got to remember here. Anytime that there's a negative under the radical, part of the simplifying that happens is if it's negative under there, an I is going to come out every time. That I stands for imaginary. It's a very unfortunate naming accident in mathematics with imaginary numbers. There were these two guys, and they were pen pals. They didn't have Twitter and Facebook and all that stuff back then. So this is a long time ago. Several hundred years. They were writing letters back and forth to each other, and they were studying mathematics. They were artists. You know, this is one of those Renaissance people that just were good at everything, but they were trying to get better at math, and they were writing letters back and forth to each other, and they were kind of competitive, so they would write a problem and say, solve this. And they got to writing polynomial problems, and they were able to solve a lot of them. And then they got into, okay, well, what if this happens? I want to give them a problem like this. And they got to finding out, well, we know that there should be, with a quadratic, how many answers are there? Anytime that we've solved a quadratic so far in chapter 4, how many answers did we get? 2 every time. So they knew there had to be 2 answers, but sometimes they couldn't find the number that they were. Like they would solve it. Maybe they'd use square roots to solve it. Maybe they'd use factoring to solve it. But there were times where they couldn't find that number that it was. They couldn't draw it on a graph and get it to show up. They knew that the answers should be something related to this graph, but they couldn't get them to show up on the graph on some problems like they could the ones they really knew how to work. And they ended up with this thing, and they said, well, there are 2 answers to this problem, but I can't tell you which ones they are, so I'm going to call them 2 imaginary solutions. And they started doing it that way. And that's where it caught on. They said they're imaginary because we don't know how to find them. And then as society goes on, they learned how to find them. Okay. But the name imaginary stuck. We call them complex answers now, but imaginary is where they came from. So the I is the abbreviation they would use for imaginary. And it's just complex numbers. That's what we call them there. And it came from taking the square root of a negative number is what they were discovering as they were going through this.
So I is the right answer.
I is going to be what you're going to pull out when you simplify the square root of a negative number. That's what you're going to need to know. Okay.
Next test, I don't know.
Yes, it can. Yeah, the graphic calculator can simplify the i's, but it won't simplify like the radical part. So like if we're going to simplify, so we're just looking at some basic radicals like -36 underneath the radical. Because it's a negative number under the radical, we know an I is going to come out automatically. And then we're going to simplify that square root the way we did last week. What's the square root of 36? 6. So that's 6I. And that's the answer to that. Where it gets a little bit tougher is maybe there's a -24 there. Well, I know it's a negative number under the square root, so I know what for sure is going to come out. An I. But then I'm going to break down 24 the same way we did last week. 24, 12 and 2, 4 and 3, 2 and 2. So it's a pair of 2s. And then, so a 2 is going to come out with that I, and there's a 6 left over inside. That turns into 2I radical 6. And it's a complex number because it's got the I part there. Same thing happens if it's a -48 under there. I'm going to break down the number the same way we did last week. Put your phone away, please. Like off your desk. Not even, just put it away where we don't even have to deal with that. All right, 48 I know is 24 times 2. And then 24, I could do 6 times 4, 3 and 2, 2 and 2. There's a pair of 2s. Here's another pair of 2s. So that's 4. And then what else comes out? I, because it was a negative. And then what's left in the inside? 3. So that, it's not really complicating the simplifying process any. Just put an I. If it's a negative number inside of the radical, you're just going to pull an I out with whatever else comes out. Okay, that's really the mechanical part of it. Okay, now what happens here when we start talking about working with the complex numbers is we got to start talking about operations with them. So let's start looking at some operations with complex numbers. Complex numbers are normally in this form: a plus bi. A and b, they're just numbers. Okay, so if we're going to write an answer in complex form, it needs to be the plain number first, plus, or if it's a negative number, minus, then the imaginary part. So there's a real part and an imaginary part. So that's what makes it complex, is you got 2 parts. You got the real part's the A, the bi, that's your imaginary part. So that's what makes it complex. That's where that's coming from. Okay. All right, so let's look at some operations. Basic operations, really easy thing to do here when it's addition and subtraction. So example D, let's add 2 complex numbers. 8 plus 2i plus this other complex number, 10 minus 3i. It's done just like terms in polynomials. What are the like terms? What's like 8? 10. 8 plus 10 is 18. And then 2i plus negative 3i minus 1i. And you've got that cranked out for you. So adding and subtracting is really, really easy. Example E, say we had negative 6 plus 4i minus another complex number. Let's do 5 minus 3i. So again, it's like terms. Negative 6 minus 5, negative 11i, or negative 11, and then the I part. 4 minus negative 3 plus 7i. Not very difficult at all.
Okay, so if the I is a positive, it's minus I, but if it's a negative, it's plus I?
All in the sign that's right here. And here we have a plus, so we're, whatever the sign it is, it stays. This negative is like distributing to the 5 and to the minus 3, so that's what changed the sign of it. The I doesn't really affect it on the addition and subtraction. It's just like terms. So we had negative 6 minus 5. That's how we got negative 11. Then we have 4 minus a negative 3. Double negative, made it a plus.
If somebody just listened to this lesson, they think we're crazy because we keep referring to the I.
Mm-hmm. It's okay.
Minus an I.
Subtract an I. If you subtract an I, you have to add a patch, right?
Right.
All right. All right, let's look at another one. Let's say we had something like 2/3 plus 7i, and then an addition of 1/5 minus 2i. Okay. So again, it's like terms. 2/3 plus 1/5. I think like denominators. So that's going to be 10 over 15. That'll be 3 over 15. Should be 13 over 15 when I add them. And then the I part, 7 plus negative 2. It's 5. That's
No, it's not going in the middle of it, you just put
whatever's there.
on that.
It's going to be in the problem that you get. Or the sign that's in the middle will be there. Whatever sign that result is, if it's a positive, it's plus. If it's a negative, it'll be minus. Kind of
10 or 15 through
like denominators, 2/3. 5 times 3 is 15. 5 times 2 is 10. This needs to be a 15. You can type it in your calculator if you want to. I just didn't want to.
Okay.
I just didn't want to do. Yeah, I just did the common denominators on those. I didn't have to do common denominators on the i's because they were just regular numbers. Okay. All right. So adding, subtracting, it's like terms, just like what we've done with x's and whatever variable is in there. There's nothing changed about that. Now, there's a little definition we need to work with here before we get into the multiplying of complex numbers. That definition is I is equal to the square root of -1. So if I square I, that's going to square the square root of -1, which would give me -1. And then if I cube that, that's going to be -I, and then I to the 4th is +1. That little chart right there, need to know that. It's going to be useful when we do the multiplication, because when we multiply I times I is I squared. But I squared is really -1. Because we want to end up with, when you multiply two complex numbers together, you want to get a complex number back. You don't want to get something that's got I squareds in it, I to the 4th powers in it. So we've got to know what these are so that we can simplify a little further. By definition, these are the things, we need to know these things, okay? That if we see an I squared, we're going to change it to a -1. If we see an I to the 4th power, we're going to change it to a +1. So we see an I to the 3rd power, we're going to change it to a -I. To simplify is what we're trying to do there, okay? So let's look at an example. Maybe a basic example here. 4I. So we got, it's just an imaginary number times a complex number, 3 plus 2I. Okay, so what property does that look like? That's exactly what it is. It's distributive property. So when I multiply that, 4 times 3 would be 12I, and then plus 8I squared. Now I got to fix it. Okay?
What do you do? 8 times -1?
That's exactly what, because I squared is -1. This turns into 8 times -1. 12I doesn't change any. Just the I squareds change there. And so when I rewrite it in complex form, remember the plain number goes first. So 8 times -1 is -8. And then the I part. And that's the final answer. And it does need to be in that order. Sounds picky, but that's the way complex numbers are written, in that order. Plain number first, I part last. It's not really that bad. Let's look at -5I times 10 plus 6I. So here we're taking a purely imaginary number and multiplying it by a complex number. So it's just distributive property, though. It really doesn't matter if you -50I minus 30I squared. What's that going to turn into? +30. Yeah. Just know it changes the sign. That's all it does. Is it makes it 30 minus 50I. Not bad at all.
Wouldn't that be -30 plus 50?
This changes to be +30 because it's -1 times -30 is +30. This is still a minus 50I. it's negative 50i. So that's where. Okay, so it's not bad. Gets a little bit more complicated when we go to the next thing where we're taking a complex times a complex. And we're gonna do this one by hand, and then I'm gonna show you how to do this with a calculator, because it'll do it. Destiny's already discovered it does some things with eyes for us already. So I want to show you that because it can help you. 9 minus 2i and 3 plus 4i. That's just like multiplying two factors together to get a polynomial. It's really all that is. FOIL method, you may have heard it called that. Double distributive property is what I call it, just because you're doing distributive property twice. You're distributing 9 to both of those, and then you're distributing negative 2i to both of those, and you're done. After you simplify it. Yeah. Yeah, you should end up with four things to put together. So 9 times 3 is 27. 9 times 4i would be 36i. And then I'm going to multiply by negative 2i to both of those. That'd be negative 6i and negative 8i squared. Now we just need to put like terms together and fix anything that needs to be fixed. What's that turn into? Negative 8 times negative 1 is positive 8. So 27 plus 8 would be 35 plus 30i. That's kind of handy. All right, let's look at it on the calculator. I said we would. There. Oh, come on. Calculator. Wake up. All right. So on the calculator, it has an I that you can use. It's down there on the bottom at the decimal point. If you hit second and then decimal point, I think is where it gets the I. So you can type that in just straight way, just like it is, and it will handle that for you and give you the answer in complex form.
Oh, and it even says second I squared is negative 1.
It does. So I would put parentheses and then 9 minus 2i, and then another set of parentheses, 3 plus 4i.
Where's the parentheses?
Up right above the 8 and the 9. And there it cranks out this complex solution. If anybody's not doing that, because it may be a setting. Yeah, the blue part written right above the decimal point. So you have to hit second and then the decimal point to get it to do that. It'll do the multiplication, and then it'll even do the addition and subtraction for you with that. Okay. Second, and then the up and down arrows.
You can do it on these.
Yeah, you can. It's just not as noticeable. It does the contrast is what it does.
Yeah, it does, because it's all gone.
Yeah. And it'll
turn it all the way up.
And it'll get it.
And it comes back. Golly, it never go up on black.
Now the darker on the black and white versions, the darker you have that, the quicker your batteries will run down. On the color versions, the brighter you have your screen, the quicker it'll run down, just like a phone. If you have your screen real bright. Just set it to where you could at least till you could see it, and then don't go any darker than that. That's usually what I usually do. It just makes the batteries last longer. All right.
Well, mine ain't doing nothing.
All right. Let's look at. Let's look at what if there's an I in the denominator, like we deal with fractions, like division of those things. We got to take care of that because remember we can't have a radical in the denominator. That's a no-no. So let's just start with a simple one, 3 over I. How would we rationalize that? Yeah, times top and bottom by I. And what that turns into is 3i over I squared, but we know I squared is -1, and we can simplify that to be -3i. In your calculator, if you go 3 divided by I, hit enter, it fixes it for you. Okay, so there's some nice things that happen with I. It doesn't do the radicals at all, but it will do the complex things for you out of that, which is nice, I guess. Let's look at another one here. What if it's a little bit more complicated and you've got 5 over 6 plus I? I don't know what letter we're on. Okay. They're not like terms. You can't put 6 plus I. It's 6 plus I. It's not 6I. So how did we fix them Friday when there was, or Thursday and Friday? The conjugate, which is what? 6 minus I. So this is how we fixed them.
Why wouldn't you do the square root of
Because what do you mean?
Because I is the square root makes it more.
Right. It does, but you're going to have to rewrite it with a 9 in it anyway, so why don't we change it back? And then multiply that out. So that's 30 minus 5i. And then on the bottom, 6 times 6 is 36. We know the stuff in the middle is going to cancel out, so we just say I times I is I squared, and it's a minus because it's plus times minus. And then simplify that. 36 plus 1 should be 37. And then you 30 over 37 minus 5 over 37 I. This is the standard form for that. That you have an A plus or minus and the BI. Okay, so here 6 times 6 is 36. I times I is I squared, but it was positive times negative, so it's a minus sign right there.
Why'd you get a plus one over it?
Because what's I squared? -1. Minus -1 is plus 1, yeah. So that's where that plus is coming from. And then I'm just splitting this into 2 separate fractions. And I would simplify if it would. It doesn't on this one. Okay. Your calculator will do that for you. You just got to be able to type it in the right way.
I got 6 plus I.
Yeah. 6 goes into 30 5 times, and it goes into 36 6.
I got that. Did you put it in like that? If you don't put the bottom part in parentheses, it does it wrong. It reads it as 3 over 6 plus I, which would be 1/2 or 0.5 plus I. So you got to put the denominator in parentheses if there's more than one. So just be careful of that. That's one of the, I guess, nuances of the calculator out there. But mine is set to give me decimal answers first, and then I convert to fraction. Remember, that's math, enter to convert to a fraction.
No way to change that.
Yes, you hit mode, and then depending on what version you've got. Some of them have the version of the right here, the answers. I've got mine set to automatic. Or DEC is going to be decimals always, and then you can change it. I want to think the newest one maybe has a fraction option here. There's a newer operating system than this one that I've got, which I need to upgrade. Haven't done that yet. Yeah, the mode, and I always just set mine to decimal anyway, and then do fractions after that. That's just what I've always done. I guess that's why I do it that way. That's what I've always done. Okay. All right, so we see how to work with the complex numbers. You know, they're pretty easy to work with. Where are they useful? And that goes back to the solving by square roots is where we're going to use those. So let's look at a couple examples of that, and then believe it or not, we're going to be done. So, all right, let's look at this one. 2x squared plus 11 is equal to negative 37. Good number that works out pretty decently here. So if we're going to solve by square roots, that's what we've been doing that for the last couple of days. What do I want to get by itself? The x squared. That's right. So to get x squared by itself, the first thing I have to move is what? The 11. So I'm going to move that by doing what? Subtracting. That's going to be 2x squared is equal to not just 48, but negative 48. Makes a big difference. And then what? Divide by that 2. X squared is equal to negative 24. And now here's where I take the square root of both sides. Don't forget, when you take that square root, it's plus or minus in front of it every time. When you take that square root to solve, you got to have the plus or minus in front of it. Okay. Then simplify that radical. I know it's a negative, so I know an I is going to come out. Then maybe some other stuff. We've already done 24 today, so that shouldn't be too much of a stretch. I'm doing it a different way because I'm bored of doing it the same way over and over. Pair of 2's, so a 2 and a 6 left over on the inside. So that's the solutions to that equation. Positive 2i radical 6 and negative 2i radical 6. It's the solution to that. 2 solutions out of that. Okay. Any questions about that one? Next one's a little bit more complicated, but not much. It's kind of similar to 33 that Kylie asked about at the beginning of class. All right, let's look at this one. Say we had parentheses x minus 3 squared plus 19 is equal to 1. What do we do first? Subtract 19. Gives us negative 18. Is the squared part by itself? Is it not? Yeah, this part, this whole stuff, this is the squared part. So we want it by itself, and it is. So now I can take the square root of both sides. Plus or minus in front of the number. So that's going to be x minus 3. And then we need to simplify that radical 18. Or excuse me, radical negative 18. 9 and 2, pair of 3's. So what's that going to be on the right-hand side? Plus or minus what? 3i radical 2. There's a pair of 3, so the 3 comes out, 2 stays in. And then add 3 to get x by itself. And that 3 here is not a like term with this guy. This has the I and the radical 2 on it. So it's just 3 plus or minus 3i radical 2. Those are the 2 answers for that equation. And if you plug 3 plus 3i radical 2 in for x and worked it out, it gets you the same thing as 3 minus 3i radical 2 does in there.
Oh, no wonder that didn't look right. That's a different one we already had.
Yeah, be careful of that. Let's look at one more. Believe in the overload principle. You do something harder than you're going to have to do, makes the stuff you have to do seem easier, right? Like weightlifting principle. Because I don't think those guys out here have to push anybody that weighs more than 500 pounds around, do they? But they pick up more stuff that weighs more than 500 pounds when they do squats and stuff like that. So overload principle. So here we go. Let's say 3 parentheses x minus 7 squared. Minus,
Pick up on 500 pounds.
I don't know. It's a pretty strong guy out there. Minus 7 is equal to negative 16. Okay. This was a lot like number 33 from Friday. So what's the first step? Add this 7 over here to the negative 16. It'd be negative 9, right? Now what? That's that they get the squared part by itself, divide by 3. Good job. That's right. So x minus 7 squared is equal to negative 3. Now what? Yeah, square root both sides because the squared part's by itself. Now what comes out of the radical negative 3? An I. Is anything else? No, because 3 doesn't break down any. So it's just I radical 3. Now we're one step away from getting the right answer. Plus 7. Good job. 7 plus or minus I radical 3.
Why wouldn't it be plus or minus 7?
Yeah, I like it.
Because 7 is added to both sides, and it's not a like term with this, so you can't combine it with that. So the plus or minus was on this first. So we're really dealing with two equations. We're really dealing with two equations that x minus 7 is equal to I radical 3, and then the other one is x minus 7 is equal to negative I radical 3. That's the two equations that we're saying when we put the plus or minus in there. We're saying, oh, this means we're dealing with these two separate equations. That's what we're doing. We're just doing it in one step because it's the same answer for both of them. Just one's a plus, one's a minus. All right, so let's look at a few problems from this section. Some good stuff here. On page 279, let's start with number 3. Let's go to 33. Nah, just do all of them. You gotta.
It was like 3 to 5.
Oh, you can do 3 to 5. I don't think it'll get you ready. It won't be enough practice. I promise. You'll get into the conjugates and all that stuff. So 3 through 33 on that page. You should be able to get this done before the end of the day. I mean, it really is that easy. The harder part is at the beginning. Okay.